localhost 5070. And let's see where the data got imported. One important thing to note, I have not specified target directory. So by default, the data will be imported to this folder, user, edureka, and employees. So here you can see the 4 different part files where our data got imported. So you might be thinking, why 4? Correct? Here I have not specified the number of mappers. So by default, it takes the number of mappers to 3 and then gives the output in 4 different part files. So let's open the part file and see how the output will be. So here you can see the data is imported from RDBMS to HDFS. There's lots of data being present over here. I'm just scrolling down and it's not coming to an end. Similarly, the output will be same in the other part files as well. So this is all about the simple scope import command without specifying the target directory and the number of mappers. Now let's see how to import the data from RDBMS to HDFS by specifying the target directory. This part remains out to be the same. Now I will do one thing. I'll specify the number of mappers as 1 so that your output will be in just one single part file, and then I will specify the target directory as well. And I will name the target directory as employee10. Enter. Again, it takes a lot of time to execute because there is a lot of data present in the database. So it got executed and retrieved these many records. Again, you can see the map reduce framework, the number of bytes written, number of read operations, write operations, etc. Now again, let's go to the HDFS browser and see the output. So I had specified the target directory name as employee10. So you can see it here. And the output is just in one single part file because I have specified the number of mappers as 1. In this case, you can control the number of mappers independently from the number of files present in the directory. So the entire records will be present in one single part file. So this is the output. Now, let me tell you how to import the command using where clause. Here you can import a subset of the table using the where clause in scoop import tool. It executes a corresponding SQL query in the respective database server and stores the result in a target directory in HDFS. So this is how the command goes. The same command as before. I'll just change the name of the target directory. I'll specify employee11 and I will increase the number of mappers to 3. And here I will specify the where clause. So let's give a condition like where the employee number will be greater than 49,000. It should display the output. Enter. So what you expect your output will be. So here it displays the output records of the employees whose employee number is greater than 49,000. So here it retrieved these many records which are above the employee number 49,000. Now let's check the output. So I have specified the target directory name as employee11. So here you can see the output that it has retrieved the records of employee number which is more than 49,000. So I hope you understand how to do this. Next, let's see how to import all the tables from the RDBMS database server to the HDFS. Here, each table data is stored in a separate directory and the directory name is same as the table name. It is mandatory that every table in that database must have a primary key field. The command will be simple like simple import, but just that you have to remove the table name and you have to replace the import with import all tables. That's all. So it will retrieve all the tables present in the employees Okay, so it imported all the tables from RDBMS to HDFS. Now let's check the output. Again, I have not specified the target directory file. So by default, it will be in user edureka, and you can see here it imported all the tables present in the database to HDFS. So these are the various tables present in RDBMS, and now it is present in HDFS. So this is how import all tables command works. So this was all about executing import command in various ways. Now let's move further and see how the scoop export works. It exports the data from HDFS to RDBMS, correct? Again, the command goes very simple. You have to specify the connection, your table name, username, and instead of the target directory, you have to specify the export directory path. So let's see how it works. One important thing to notify, the target table must exist in the target database. That is, the data is stored as records in HDFS and these records are read and passed and delimited with the user-specified delimiter. The default operation is to insert all the records from the input files to the database using the insert statement. In update mode, Scoop generates the update statement that replaces the existing record in the database. So first we are creating an empty table where we will export our data. I'm going to create a table called employee 0. The primary key value should never be null, so I'm specifying it as not null. So here I created an empty table called employee 0, and now I'll show you how the Scoop export works. Here, instead of import, I'll make it as export. This is the database name, and I have created a table called employee 0, and I'm going to specify the path for export directory. Simple, that's all. So you can see here it exported all these records into the RDBMS. So now let's cross-check. I'm going to give select count star from the table name that I have specified to export the tables. So you can see the entire records got exported to this table. So this is how the Scoop export works. Now let's see how to list the database present in the relational database. Here, you need not even specify the database name because you're going to list the database that is present in the relational database system. So you're going to specify list databases and execute the command. So the databases present in the relational database system is test, JDBC test, employees and information schema. Again, let's cross-check. I'm going to give show databases. It retrieved the same database. So the result tallies. So we can also list the tables present in the database. Let's see how to list all the tables present in the database. Again, it's very simple. You have to just specify the database name, like here, and give list tables instead of import. So you can see that it listed all the tables present in the database, employees. So again, let's cross-check. Show tables. Same thing. And now let's see what is CodeGen. In object-oriented application, every database table has one data access object class that contains getter and setter methods to initialize the objects. And CodeGen generates DAO class automatically. And it also generates the DAO class in Java based on the table schema structure. So this is a simple command. Let's see how to execute it. Here I will give Scoop CodeGen and give the connection and the database name as employees. Then I'm going to specify the table name as well. So it is going to create an employee jar file in which the backend code will be generated. So I'll copy this path and jump into this directory. So you can see here that it created employees class, jar file and the Java object file as well. So now let's open the file system and check for the file. So what was the name of the file? It ends with 539D9. So here is the folder. So in this you can see the object file that is being generated. So this is the backend code that is being generated. So this is all about how the Scoop CodeGen works. Why do we need Flume for data ingestion? Let's take a scenario here. Say we have hundreds of services running in different servers and that produce lots of large logs which should be analyzed together. And we already have Hadoop to process these logs. So how do we send all the logs to a place that has Hadoop? It's obvious fact that we need a reliable, scalable, extensible and a manageable way to do it. So to resolve this problem, Apache Flume came into picture, which is the most reliable, distributed and available service for systematically collecting, aggregating and moving large amounts of streaming data into the HDFS. And that's why and where we need Flume. So what is Apache Flume? By now, you all might have thought that Flume is a tool for data ingestion in HDFS. It collects, aggregates and transports large amount of streaming data such as log files, events from various sources like network traffic, social media, email messages, etc. The main idea behind the Flume's design is to capture streaming data from various web servers to HDFS. It has very simple and flexible architecture based on streaming data flows. It is fault tolerant and also provides a reliability mechanism for failure recovery. Again, Flume can easily integrate with Hadoop and dump all the unstructured as well as a semi-structured data on HDFS, and that complements the power of Hadoop. This is why Apache Flume is said to be the most important part of Hadoop ecosystem. Now let's move further and see the benefits of Flume. There are several advantages of Apache Flume which makes it a better choice over others. I have listed some of the benefits. Flume is scalable, reliable, fault-tolerant, and customizable for different sources and sinks. It can also store the data in centralized storage like HBase, HDFS, etc. If the read rate exceeds the write rate, Flume provides a steady flow of data between read and write operations. Flume also provides a reliable message delivery. The transactions in the Flume are channel-based where two transactions are maintained for each message. That is, one sender and one receiver for each message. Using Flume, we can ingest the data from multiple servers into Hadoop. And it also helps us to ingest online streaming data from various sources and supports a large set of sources and destination types. So let's see what's next. The architecture is the one which is empowering Apache Flume with its benefits. Now, as we know the advantages of Apache Flume, let's move ahead and understand Apache Flume's architecture. One important thing to note here, there's a Flume agent which ingests the streaming data from various data sources to HDFS. From this figure, you can easily understand that web server, Facebook, cloud, social media, all these indicate the data source from where we are getting the data. And Twitter is among one of the famous sources for data streaming. And now coming to Flume agent, it comprises of three components: source, sink, and channel. First, source. It accepts the data from the incoming streamline and stores the data in the channel. Now coming to channel, in general, the reading speed is faster than the writing speed. Thus, we need some buffer to match the read and write speed difference. Basically what happens, the buffer acts as an intermediary storage that stores the data which is being transferred temporarily and therefore prevents data loss. Similarly, channel acts as a local storage or a temporary storage between the source of data and the persistent data in HDFS. Now coming to our last component, sink, it collects the data from the channel and commits or writes the data in the HDFS permanently. So this is all about the working of Flume architecture. As we know how Apache Flume works, let's take a look at the practical where we will sync the Twitter data and store it in the HDFS. In this figure, you can see there is lots of data generated from Twitter. Now you want to go ahead and stream this data. So how will you do it? For this, we have Apache Flume, which will help us to do the real-time data streaming of Twitter data and store it in the HDFS. So let's see how to do it. So first, we will create an application and get the tweets from it. Here we use the experimental Twitter source provided by Apache Flume. So here we will use memory channel to buffer these tweets and HDFS sync to push these tweets into the HDFS. The first step is to create a Twitter application. For this, you have to go to this URL, that is apps.twitter.com, and you have to sign in to your account. If you do not have developer account, you have to apply for the one by completing the form. As I already have a developer account, I'll just click on developer.twitter.com and click on my profile and choose apps. So here you have an application called create an app. Here you have to fill these required fields. First, app name. Now while filling the website address, you have to give the complete URL pattern like this. And then you have to specify how this app will be used. I'll say something like this. So after everything is done, you have to just click on create. So your application got created. Now click on keys and tokens. And here you will find something called as consumer API keys, then access token and access token secret. You have to regenerate this and you have to create an access token keys. Now you got the API key, the API secret key, the access token and the access token secret as well. So copy the key and access token. So you might be thinking why you need to copy these things. We need to pass these tokens in our Flume configuration file to connect to this Twitter application. So I'm going to copy this. Make sure you copy it properly. Now Let's create a Flume configuration file in the Flume's root directory. I have already created a flume.conf file. I'll show you how to specify the parameters. As we have discussed in the Flume's architecture, I have configured source, sink, and channel. Here, our source is Twitter, channel is memory channel, and the sink is HDFS. In source configuration, we are passing the Twitter source type as this. Then we are passing all the 4 tokens which we have received from Twitter. That is the keys and the secret keys that I have copied. Make sure you paste them properly. At last, in the source configuration, we are passing the keywords on which we are going to fetch the tweets. So I have specified some keywords like Spark, Hadoop, Big Data, Analytics, Cloud Computing, etc. Now in the sync configuration, I have configured the HDFS properties. That is, HDFS channel as memory channel. The type will be HDFS. The path of HDFS where the Flume tweets will be stored. The file type, the write format will be always text. Remember that. The batch size, the roll count, etc. And at last, we are going to set the memory channel properties like the type, capacity, and the transaction capacity. Now, save this file and close it. For my convenience, I'll copy this file from Flume directory and paste it in the home directory. Okay. Now we are all set for execution. Let's go ahead and see how to execute this command. Now I have placed a flume.conf file from the Flume's root directory to home directory. So I'll go back to the home directory and then run the command. The command goes like this. That is flume ngh conf file path, that is home edureka, and the conf file name. The name will be Twitter agent, and dflume.root.logger will be debug.console. Enter. Now it started executing. So you can see here it started processing the records and created this Flume tweets folder. In that you have this file. So after executing this command for a while, you can exit the terminal using Ctrl+C. Now let's open the web browser and go to HDFS Web UI. So here in the mention path, you can check the file that is present. So here you have Flume tweets. Click on that. So this is the output file where the data will be streamed. So this is the output where you can see the tweets from the followers. Someone is saying, as a survivor of a politically motivated attack, it's tragic to think this is an acceptable state of political discourse. It depends, like whatever you follow, and you will get all those things. And here someone is saying, Youth Association for Transforming National Kulu based on NGO working in the field education, environment protection, health, and general awareness among the people. So this output is nothing but the live data streaming of Twitter data.
What is Apache Pig? So Apache Pig is an abstraction over MapReduce. It is a tool or platform which is used to analyze larger sets of data, representing them as data flows. Pig is generally used with Hadoop. We can perform all the data manipulation operations in Hadoop using Apache Pig. To write data analysis programs, Pig provides a high-level language known as Pig Latin. This language provides various operators using which programmers can develop their own functions for reading, writing, and processing data. To analyze data using Apache Pig, programmers need to write scripts using Pig Latin language. All these scripts are internally converted into map and reduced as respectively. Apache Pig has a component called Apache Pig Engine that accepts the Pig Latin scripts as input and converts those particular scripts into MapReduce jobs. So this was a basic introduction to Apache Pig. Now moving ahead, we shall understand the different modes in which Apache Pig functions. There are two particular modes in which Apache Pig functions. Those are the local mode and MapReduce mode. First, we will understand what exactly is local mode. In local mode, Apache Pig is designed to execute in a single JVM and is used for development, experimenting, and prototyping. Here, files are installed and run using localhost. The local mode works on local file system, and the input and the output data is stored in the local file system. To access the command or the grunt shell in local mode, you need to execute a command called pig-x local. We shall practically execute this in the demo section. Now moving ahead, we shall discuss about the second type of mode in which Apache Pig can be run. That is the MapReduce mode. The MapReduce mode is also known as Hadoop mode. Apache Pig chooses Hadoop mode as its default mode. In this, Pig renders Pig Latin into MapReduce jobs and executes them on a Hadoop cluster. It can be executed against semi-distributed or fully distributed Hadoop installation. Here, the input and the output are present on HDFS. The command for executing pig in MapReduce mode is pig or pig-x MapReduce. Again, we shall discuss about this particular command in our demo section, where I'll show you both the modes and execute the pig scripts there. Now, followed by the pig modes, we shall understand the ways to execute pig program. So basically, the pig scripts are executed in three particular modes. Those are interactive mode, batch mode, and lastly, the embedded mode. Don't worry, I'll explain to you each of these modes. Firstly, we shall discuss about the interactive mode. In this particular mode, the pig is executed in a grunt shell. To invoke grunt shell, run the pig command. Once the grunt mode executes, we can provide pig Latin statements and command interactively at the command line itself. So the next mode is the batch mode. In this particular mode, we can run a script file having a .pig extension. These files contain the pig Latin commands. So basically what we do is we write the pig command or the pig script and store it in a location. And using the terminal, we will access that particular location and that particular file and run the code present in that file. So this is what happens in batch mode. So followed by that, the last mode is the embedded mode. In this particular mode, we can define our own functions. These functions can be called as user-defined functions. Here, we use programming languages like Java and Python to define our own user-defined functions. So these were the three different modes in which we can execute pig scripts. Now moving ahead, we shall enter into our next topic, that is the features of pig. So there are 5 different and important features of pig. So first up, we shall understand the ease of programming. Writing complex Java programs for MapReduce is quite tough for non-programmers. Pig makes this process very easy. In the Pig, the queries are converted into MapReduce processes internally. So obviously, it has grown the ease of programming. Followed by that, the next important feature is the optimization opportunities. So what exactly is optimization? It is how the tasks are encoded permits the system to optimize the execution automatically, allowing the user to focus on semantics rather than efficiency. So followed by the optimization, we have the extensibility. A user-defined function is written in which the user can write their logic to execute over the datasets. So this increases the extensibility of the programmer. Followed by that, the next important feature is it is highly flexible. Apache Pig can easily handle structured as well as unstructured data. So Apache Pig tool is considered to be highly flexible, irrelevant of the data type. Followed by that, the last and important feature is inbuilt operators. Apache Pig contains various types of operators such as sort, filter, joins, and many more, which are inbuilt. So here, the programmer doesn't have to program these functions externally. Instead, he can just directly get an access to those inbuilt functions and execute them. So these were the 5 important features of Apache Pig. So the next topic in our today's discussion is Apache Pig installation into our local system. Now we shall discuss about one of the easiest ways to install Apache Pig into our local system. So today, I'll explain you how to install Apache Pig into Windows operating system. So to do this, the easiest way is to download one of the virtual machines. So I would prefer you to download Oracle VirtualBox for this particular task. Followed by that, we shall also download a quick start VM of Cloudera. Don't worry about the softwares, I'll drop down the link for those softwares in the description box below. You can use that and download them. So once after the Oracle VirtualBox is installed into a local system and it is running, this is how it looks like. Now, what we want to do is to add a new virtual machine into our VirtualBox. So for that, you just need to select import option and it will give you a new dialog box. And from here, you must redirect to the location where your VirtualBox is located. So in my system, it's located in F drive, and inside F drive CCA Cloudera VirtualBox Cloudera Quick Start VM. So there you go. Now you just have to select open, and before we actually select the button import, you might want to select the RAM and increase its size to at least 8 GB. So I'll just write in 9000 MB, which is just a little above 8 GB. Now we are good to go. Just select the option import and your VirtualBox will be imported. You can see that the quick start VM is getting imported. Now you can see that the virtual machine got successfully imported. Now to start it, all you need to do is just click on it and then select the start button. So you can see that the Cloudera Quick Start VM version 5.13.0 has been successfully imported and booted up. Here we are. We have the Quick Start Cloudera VM welcome note. And now if you want to start up with Pig Editor, you might want to log into Hue first or your HDFS. Remember, in Cloudera, the default username is Cloudera and the password also is Cloudera. Now let me tell you, in Cloudera, the default username and password for everything is Cloudera. For example, let's log into our Hue using the username Cloudera and password Cloudera. Now you might want to just select remember to remember your password. And there you go, you have successfully logged into Hue. And now, if you want your query editor for Pig, you can just select the bottom arrow mark and there you can select editor, and inside editor you have the editor designed for Pig. Now you are in the window where you can write Pig scripts and execute them. Now we will move ahead into our next topic, and after finishing the theory part, we shall come back into our Cloudera and execute some of the basic operations on Pig terminal. So our next concept is understanding the Pig architecture. So first of all, let us go through the diagram of Pig architecture. The following diagram represents the architecture of Apache Pig. As shown in the figure, there are various components in Apache Pig framework. Let us look at the major components. Firstly, the parser. Initially, the Pig scripts are handled by the parser. It checks the syntax of the script, does type checking and other miscellaneous checks. The output of the parser will be a DAG, which is directed acyclic graph, which represents the Pig Latin statements and logical operators. In directed acyclic graphs, the logical operators of the scripts are represented as the nodes and data flows are represented as edges. And next, the optimizer. The logical plan for directed acyclic graphs is passed to the logical optimizer. This carries out the logical optimizations such as projections and pushdowns. Next comes the compiler. The compiler is used to compile the optimized logical plan into the series of MapReduce jobs. Followed by that, we have the execution engine. Finally, the MapReduce jobs are submitted to the Hadoop in a sorted order. Finally, these MapReduce jobs are executed on Hadoop, producing the desired results. So this was a basic explanation based on Apache Pig architecture. Now moving ahead, we shall understand the major advantages of Apache Pig. So some of the major advantages of Apache Pig are less code. The pig consumes less than a line of code to perform any operation. So this reduces the number of lines included in the code. Followed by that, code reusability. The pig code is so flexible enough to reuse it again. You can basically write the pig script into a file and access the file whenever you need it. So followed by that, the next important advantage of Apache Pig is the nested data types. The pig provides a useful concept of nesting data types like tuple, bag, and map. So these were the few important advantages of Apache Pig. Now we shall move ahead into the next topic, which is about the differences between Apache Pig and Apache MapReduce. So there are basically four differences between Apache Pig and Apache MapReduce. So first up, we will begin with MapReduce. In MapReduce, we have low-level data processing. When it comes to Apache Pig, it is considered as a high-level data processing tool. Followed by that, the next important difference between MapReduce and Apache Pig is that we find complex Java programs when we are using MapReduce. But when we come into Apache Pig, we have simple programming scripts, which are shorter in code length and easily understandable. Followed by that, the third difference is the data operations are completely tough and complicated in MapReduce. But in Apache Pig, you don't have to worry about those operations because they're already built in. Next, and the last difference between MapReduce and Apache Pig is Apache MapReduce does not allow nested data types, whereas Apache Pig allows nested data types. So these were the basic differences between Apache MapReduce and Apache Pig. So the next topic is the Pig demo. Here, we will understand all the basic commands in Apache Pig and the basic functionalities which are available in Pig. Now, without further ado, let's quickly begin with our demo for today's session. Now, we have come back to our Cloud Era that we have installed into our local system. Now, let's start Pig. As we have discussed before, Apache Pig can be executed in two modes. They are the local mode and the MapReduce mode. Firstly, we shall execute an example based on local mode. To start Pig in local mode, you need to type in the command pig space -x space local. Firing this command will enable Pig in local mode. As you can see, the command is getting decrypted. Now you can see that it has successfully started the grunt shell in local mode. Now what are we going to execute? We are going to execute a very simple word count program. For this particular word count example, I have considered a basic text, that is the definition of Apache Pig, which happens to be Apache Pig is a high-level platform for creating programs that run on Apache Hadoop. The language for this particular platform is called Pig Latin. Pig can execute its Hadoop jobs in MapReduce, Apache Test, and Apache Spark. So we will consider this particular paragraph, and we will also count the number of words which are included in this particular paragraph. Now let's quickly go back to our terminal and execute our program. So now we have come back to our terminal. Let's clear it using the command Ctrl+L. Now let's quickly start up typing our commands. So as discussed before, we are going to execute this particular program in local mode. So here we are not loading the data into HDFS. Instead, we are considering the local location, which is the local location that is home Cloudera desktop word count. Now we're going to run this command and see the output. So the data has successfully loaded. Now we'll execute the next command. So now we're going to tokenize each and every single word in this particular paragraph, and we'll be considering each and every word as a single word, and we are going to separate each and every word by using a space. Now let's fire up this command and see the output. Yeah, the command just got executed, or the script just got executed. Now in the next script, we are going to group the words according to their occurrence. Yeah, even that is done. Now the next script would help us to count the number of words which have been repeated. So even that is done. Now the last script would be dumping the output which is stored in p word c, which is pig word count. Now let's enter the command and see the output. You can see some MapReduce jobs that are getting executed, and there you go. We have our output. So the words are AN, on, for, its, days, Hadoop, Apache, and all those words. And along with them, we also have the number of repetitions of each and every word. For example, we have Hadoop, which is repeated 1 time, and the word Apache is repeated for 4 times, and so on. So with this, now let us move ahead and execute some examples based on Apache's Hadoop mode or MapReduce mode. Now let's close this terminal and open a new one, and let's begin executing Hadoop in MapReduce mode. As discussed before, Apache Pig can be executed in both local mode and MapReduce mode. We have already executed some examples based on local mode. Now we shall execute some examples based on MapReduce mode. To do so, we will first load some local data into HDFS. So using this command, I'll be loading my local data, that is pictutorial.csv, into my HDFS, and I'll name it as edureka in. As you can see, the command is getting deprecated and the data has been successfully loaded. Now let us use cat command and see what exactly is present in that particular data. As you can see, the command got deprecated and the data is a simple CSV file related to students that has ID, name, department, and year. Now let's start Pig in MapReduce mode. To do so, we just need to type in PIG and strike enter. There you go. We have successfully started Pig in MapReduce mode. Now let's execute some commands. So using this command, we will be loading edureka.in, that is the data, the CSV file which we have discussed before, using pig storage as comma separated file. And the schema for the data will be ID as character array, name as character array, department as character array, and year as integer array. Now let's strike an enter and see the output. There you go. The data has been successfully loaded now. Now let's use dump command to see the data what we have loaded. So there you go. The data has been successfully dumped. So this was the data which we have loaded. Now let's move further and execute a few more commands. Now we shall use for each command, and for each data present in our data file, we will generate ID, name, and department. There you go. The command got successfully executed. Now let's dump the data using dump command. So pig for each is our variable that stores the data. Now let's type in semicolon and enter. So there you go. The for each command has been successfully executed and we have generated ID, name, and department. Now we shall execute a few more examples. Now we shall use descending operator to arrange the data in the form of descending order of ID. So it's been executed. Now let's dump the data and see the output. There you go. We have successfully executed the dump command and the IDs are being arranged in the descending order now, as you can see it. Now this is how the order by descending function works. Now let's move ahead and execute one last command. As you can see here, we are using filter operation. We are going to filter the students based on their department, where department is equals to CSE. So executing this command will give us the students which are inside the department CSE. Now the command got executed. Now let's dump the data using dump command. So there you go. You can see some commands getting deprecated. Here you can see the MapReduce jobs getting executed. So there you go. You can finally see the output, which has the students that belong to the CSE department. Why exactly we needed Apache Hive? It all began in the early 90s when Facebook started. Slowly, the number of users at Facebook increased, that is, nearly 1 billion users and along with the users increase the data, which is nearly equals to thousands of terabytes of data and nearly 1 lakh queries, then also 500 million photographs uploaded daily. And this was a huge amount of data that Facebook had to process. And the first thing that everybody had in their mind was to use RDBMS. And we all know that RDBMS couldn't handle such a huge amount of data, and neither it was capable enough to process it. And the very next big guy who was capable enough to handle all this big data was Hadoop. Even when Hadoop came into picture, it was not too easy to manage all the queries. It used to take a lot of time to execute all the queries performed. So one common thing that all the Hadoop developers had was the SQL. So they thought to come up with a new solution that has Hadoop's capacity and interface like SQL. That is when Hive came into picture. So now we understand the exact definition of Apache Hive. Apache Hive is a data warehouse software project built on top of Apache Hadoop for providing data query and data analysis. Hive gives a SQL-like interface to query data stored in various databases and file systems that integrate with Hadoop. Also, Apache Hive has data warehousing software utility. It can be used for data analytics. It is built for SQL users, manages querying of structured data, and it simplifies and abstracts the load that is on Hadoop. And lastly, no need to learn Java and Hadoop API to handle data using Hive. So followed by this, we shall understand Apache Hive applications. Apache Hive is used in many major applications. Few of the major applications are as follows. Hive is a data warehousing infrastructure for Hadoop. The primary responsibility of Hive is to provide data summarization, query, and data analysis. It supports analysis of large datasets in Hadoop's HDFS as well as on Amazon S3 file system. Followed by that, we have document indexing with Hive. The goal of Hive indexing is to improve the speed of query lookup on certain columns of a table. Without an index, queries could load an entire table or partition a whole process as rows. This would be troublesome. So, with Hive, we have solved this problem. Followed by that, predictive modeling. The data manager allows you to prepare your data so it can be processed in automated analytics. It offers a variety of preparation functionalities, including the creation of analytical records and timestamp populations. Followed by that, the next important application of Hive is business intelligence. Hive is a data warehousing component of Hadoop, and it functions well with structured data, enabling ad hoc queries against large transactional datasets. Hence, it happens to be a best-in-class tool available for business intelligence and helps many companies to predict their business requirements with high accuracy. Last but not the least, log processing. Apache Hive is a data warehouse infrastructure built on top of Hadoop. It allows processing of data with SQL-like queries and is very pluggable so that we can configure it to provide our logs quite easily. So these were the few important Hive applications. Now let us move ahead and understand Apache Hive features. The first and the foremost important feature of Apache Hive is SQL type queries. The SQL type queries present on Hive will help many of the Hadoop developers to write queries with ease. Followed by that, the next important feature of Apache Hive is OLAP based design. OLAP is nothing but online analytical processing. This allows users to analyze database information from multiple database systems at one time. So using Apache Hive, we can achieve OLAP with higher accuracy. Followed by the second feature, we have the third feature which says Apache Hive is really fast. Since we have SQL-like interface in Apache Hive, using this feature on HDFS will help us writing queries faster and executing them. Followed by that, we believe Apache Hive is highly scalable. Hive tables are defined directly in Hadoop file system. Hence, Hive is fast and scalable and easy to learn. Followed by that, it is known to be highly extensible. Apache Hive uses Hadoop file system, and Hadoop file systems or HDFS provides horizontal extensibility. And finally, the ad hoc querying. Using Hive, we can execute ad hoc querying to analyze and predict data. So these were the few important features of Apache Hive. Let us move on to our next topic, where we deal with Apache Hive architecture. The following architecture explains the flow of submission of query into Hive. The first stage is the Hive client. Hive allows writing applications in various languages including Java, Python, and C++. It supports different types of clients such as Thrift Server, JDBC Driver, and ODBC Driver. So what exactly is Thrift Server? It is a cross-language service provider platform that serves the requests from all these programming languages that supports Thrift. Followed by that, JDBC driver. It is used to establish connection between Hive and Java applications. The JDBC driver is present in the class org.apache.hadoop.hive.jdbc.hive driver. Finally, we come to ODBC driver. So what exactly is ODBC driver? ODBC driver allows the applications that support ODBC protocol to connect to Hive. Followed by that, we have the Hive services. The following are the services provided by Hive. They are Hive CLI, Hive Web User Interface, Hive Metastore, Hive Server, Hive Driver, Hive Compiler, and lastly, the Hive Execution Engine. The Hive CLI or Command Line Interface is a shell where we can execute the Hive queries and commands. Followed by that, the Hive Web UI is just an alternative for Hive CLI. It provides a web-based graphical user interface for executing Hive queries and commands. Followed by that, the Hive Metastore. It is a central repository that stores all the structured information of various tables and partitions in the warehouse. It also includes metadata of column and its type information, the serializers and deserializers, which is used to read and write data, and the corresponding HDFS files where the data is stored. Followed by that, the Hive server. It is referred to as Apache Thrift Server. It accepts the requests from different clients and provides to the Hive driver. Moving on, we shall deal with Hive driver. The Hive driver receives queries from different sources such as Web UI, CLI, Thrift, and JDBC or ODBC drivers. It transfers the queries to the compiler. Followed by that, we have the Hive compiler. The purpose of Hive compiler is to parse the query and perform semantic analysis on the different query blocks and expressions. It converts Hive QL statements into MapReduce jobs. Finally, we have Hive Execution Engine. Hive Execution Engine is the optimizer that generates the logical plan in the form of DAG or Directed Acyclic Graph of MapReduce tasks and HDFS tasks. In the end, the execution engine executes the incoming task in the order of their dependencies. Followed by that, we have the MapReduce and HDFS. MapReduce is the processing layer which executes the mapping and reducing jobs on the data provided. Lastly, the HDFS or Hadoop Distributed File System is the location where the data which we provide is stored. So this is the architecture of Apache Hive. Then moving next, we have Apache Hive components. So what are the different components which are present in Hive? They are, first one, the shell. Shell is the place where we write our queries and execute them. Followed by that, we have Metastore. As discussed in the architecture, the Metastore is the place where all the details related to our tables is stored, like schema, etc. Followed by that, we have the execution engine. So execution engine is the component of Apache Hive which converts the query or the code which we have written into the language which the Hive can understand. Followed by that, driver is the component which executes the code or query in the form of acyclic graphs. And lastly, the compiler. Compiler compiles whatever the code we write and executes and provides us the output. So these are the major Hive components. Moving ahead, we shall understand Apache Hive installation on Windows operating system. So Edureka is all about providing the technical knowledge in the simplest way as possible and later play around with the technologies to understand the complicated parts of it. So now let's try to install Hive into our local system in the most simplest way as possible. To do so, we might need the Oracle VirtualBox which looks like this. So once after you download Oracle VirtualBox and install it into your local system, the next step would be to download the Cloudera Quick Start VM for your local system. The link to this will be provided in the description box below. Now let's quickly start our Cloudera Quick Start VM with our Oracle VirtualBox. Select Import option and now provide the location where your Cloudera Quick Start VM is existing. In my local system, it is in the local disk drive F. There you go. Select open. And now just make sure your RAM size is more than 8 GB. Just randomly I'm providing 9000 MB, which is just above 8 GB, so that you have a smooth functionality of Cloudera. Now select import, and there you go. You can see that Cloudera Quick Start VM is getting imported. Now you can see that Cloudera Quick Start VM has been successfully imported and it's ready for deployment. You can just double click on it and it'll get started. You can see that Cloudera VM has been successfully imported and it started. And also you can see that we have gone live on Cloudera. You can see all the Hue, Hadoop, HBase, Impala, Spark, which are pre-installed in Cloudera. Now our concern would be to start up Hive. So to start Hive, you need to start up Hue first. So let me remind you one thing. In Cloudera, every single password and username is Cloudera by default. So for example, we have got Hue username and password here. So the username, that is the default username for Cloudera's Hue, would be Cloudera. And along with that, even the password will be Cloudera. That is by default. So we have got Cloudera and Cloudera as username and password respectively. Let's just sign in. You may select remember option in case if you forget your passwords. So now we are getting connected to Hue and we are live on Hue now. There you go. We've got started our Hue. So now we'll enter into HDFS. There we go. We have our Hive here. Now that we have successfully installed Hive into our local system, let us move further and understand a few more concepts in Hadoop. Firstly, we shall deal with the data types. The data types are completely similar to any other programming language which we have. They are tiny int, small int, integer, big int. Similarly, followed by that we have float. And inside Hive, float is used for single precision. And if you want double precision, you can go ahead with double. And followed by that we have a string and boolean, which are completely similar to any other programming languages which we use in this daily life. Followed by that we have Hive data models. So these are the basic data models which we use in Hive, that we basically create databases and store our data in the form of tables. And sometimes we also need partitions. We will discuss each one of these data models in our demo ahead. So we'll first create databases, and inside databases we will be creating tables inside which we will be storing data in the form of rows and columns, and along with that partitions. Partitions, they are like advanced way of storing data. Like if you have, just imagine you're in a school, say standard 1, and inside standard 1 you have sections A, B, C, D. So partition is like you're getting partitions for section A, section B, section C, and section D. You're storing different students in different sections, so that when you're querying for a particular data, for example, say you're searching for a kid called Sam and you have the section of his class as B. So you just don't have to just search for Sam in all the 4 sections. You can just directly go into section B and call in Sam and you'll get access to him. That's how partitions work. Followed by partitions, we have buckets. So similar to partitions, even buckets work in the same way. Let's understand each one of these in much better way through a practical demo. After data models, we shall understand about Hive operators. So what are operators? Operators are any other operators that we use in normal programming languages, such as arithmetic operators, logical operators. We shall also go through some examples based on arithmetic and logical operators in Hive in the Hive demo. We will use some arithmetic operations as well as logical operations on the data which we have stored in the form of tables in Hive. We shall go through a brief look on that as well. So before we get started, let's have a brief look on the CSV files that I have created for today's demo. These are the small CSV files that I've personally created using MS Excel, and I've saved them as .csv files. I've made the CSV files to be smaller because just to make sure the execution time consumed is as less as possible. Since we're using Cloudera, the execution time might be a little more. So it's better we use smaller CSV files. So this is my first CSV file, which is employee.csv, which has employee IDs, employee name, salary, and age. Similarly, we have another employee2.csv file, which has the same details along with one more column, that is the country column. I've included country because we will be using this country column in joins that we will be performing in future. Followed by that, we have the department. So here we have department ID and department name. So we have development department, testing, product, relationship, admin, and IT support. Similarly, we also have student CSV. This is another CSV file that I have created. This has ID, name, course, and age of the student. Followed by that, we have another CSV. This is student report.csv, which has the reports of a particular student, gender, ethnicity, parental education, lunch, course, math score, reading score, writing score, and other. So these are the CSV files that we will be using in our demo today. So now let's quickly begin with our demo. So to start Hive, we shall open a terminal. So starting or firing up Hive in Cloudera is really simple. You just have to type in Hive and enter. There you go. Logging initialized using configuration files and etc. The Hive CLI is deprecated and migration to Beeline is recommended. And there you go. Your Hive terminal or CLI has been started. So first, let's try to create a database. To save time, I've already created the document which has all the codes that we will be executing today. So this is the particular file which I will be using today. So don't worry, this file will be linked in the description box below. You can use the same file and try executing the same codes in your personal systems just for practice if you feel so. So just to save time, I've already created the document which has the codes that we are going to execute today. So this code or this file will be attached in the description box below. You can get access to it and you can also execute the same codes in your own personal system to have a practical experience about this particular Hive tutorial. So the first thing that we will be doing today is to create a database. So I'm going to create the database using SQL type commands, which are create database, name of the database, which is Edureka. There you go. The database has been successfully created. So now you can also use the following command to check if your database has been created or not. So show databases will help you to find it. So there you go. You can see the first database, which is a default database, which will be pre-existing. And followed by that, you have our own database, which we have created now, that is Edureka. So followed by this, next we will move ahead and try to create a new table. So when you come into tables, you need to understand there are two types of tables in Hive. They are managed tables or internal tables, followed by that external tables. So what is the difference between these two tables? So internal table or managed table is the default table that will be created whenever you try to create a table in Hive. So for example, if you're trying to create a new table, say Edureka, then Hive considers that particular table as an internal table by default. So when you create an internal table, your data is not secured. Understand this. So when you create an internal table, your data is not secured. In case, just imagine you are working with a team and all your team members have access to your Hive or Hue. So the table has been existing in your Hive and some random newbie or some random inexperienced guy tries to change few things in your table and accidentally he ends up deleting the table. So when you delete the table, then if the table was created using an internal table code, then your data will be erased. So that's the disadvantage of using internal tables. But in case if you create an external table, even if somebody tries to delete your table, the table or the data, whatever is there, will be deleted from their own local system, but not from Hive. So that's the best part of using external tables. Don't worry, we will discuss about internal tables and external tables as well. So first we'll try to create an internal table. So this particular code is based on internal tables. So we are using SQL type command here, which is create table and the table name is employee. And the columns inside our table are ID of the employee, name of the employee, salary and age. So row format has been delimited, followed by that. Since this is a CSV file, so the fields will be terminated by comma. And don't forget, you have to use semicolon. Unless you use semicolon, your code is not complete. So let's fire and enter and see if the table gets created or not. Yeah, the table is created successfully. Now we shall see the table, or let's describe the table. So describing the table means you can see what are the columns which are present in your table. So to describe a table, you can use the keyword describe and name of the table, which is employee. and don't forget semicolon. There you go. So your table has the columns ID, name, salary, age. So those are the 4 columns which you have included in your particular table employee. Now let's move ahead and see if this particular table is an internal table or managed table, or the other type of table, which is the external table. So to do that, we can just write in describe formatted table name and semicolon. There might be a small issue here. Yeah, there is a typing mistake. That is describe. I missed S. So there you go. We got it. So this particular table is managed table, as you can see here. Now let's move ahead and try out external tables. Let's clear our screen first. You can use Control plus L to clear your screen. There you go. We have a clear screen now. Now let's try to create an external table. Creating an external table is completely similar to that of internal table, but the only difference is that you need to add in a keyword which is external. So this particular keyword is used to create an external table. Now let's fire an enter and see if the table gets created or not. You can see the table got created. Now let's try to describe the table, employee 2. Don't forget the semicolon. I'm saying this again and again because most of the times we miss semicolon and we will get an error. So you can see the table got described and we have the following columns inside our table. Now let's move ahead and see if this particular table is an external table or a managed table. To do so, you can type in describe formatted, the same code what we have used earlier, that is describe formatted, name of the table, that is employee 2, semicolon. Don't forget there is some issue again. I think I've missed something, or maybe a typing error. Yeah, this is a typing error. Yeah, there you go. The table type is external table. So that's how we create an internal table or managed table and external table. So now that we have understood how to create a database and table and the 2 types of tables, that are internal table or managed table, followed by that the second type of table, that is the external table. Now let's try to create an external table in a particular location. So for that, you can use the following code, but the only difference is you are specifying the location, that is user Cloudera Edureka employee. EDUEMP is a file that we will be creating in our Hive. So let's fire and enter and see it if it's created or not. Yeah, it's successfully created. Let's go back to Hue and see if the following table is created or not. So one thing you have to remember is when you fire in a command or if you try to create a table, the first folder that will be created is a warehouse. So inside Hive, you have your warehouse. And inside warehouse, you have all the databases that we have created. Our first database was the Edureka database. And after that, we have created table, which is employee. And the second table is employee 2. So this is in the particular location, which is user Cloudera. And the file is employee 2. Let's see that. This was the file. Yeah, sometimes Hue will not show it because of network issues. You don't have to worry about it. You will get back that data. Now, followed by this, let us enter into Hue again. So when you come back into Hue, if you have to upload a file into Hue, you can just select this particular option, which is plus. So selecting this will give you a dialog box, which will be something like this. And here you can just select any of the files which you want to upload into Hue. Now let me select a student report.csv and select open. So there you go, upload is in progress. So the data file has been successfully uploaded. Now if you want to access your data file, you can just click on that. So there you go, you have all your data successfully loaded onto Hue. You can also perform queries on this particular data. You can just select query, and inside that you just need to select editor, and you have various editors over here, which is Pig, Impala, Java, Spark, MapReduce, Shell, Scoop, and we also have Hive in here. So if you just select Hive, and there you go, you have the editor here. You can just type in your commands or queries, whatever you have. See, you have many dictionaries as well. You can just select any one of those, select, and that's how you write queries on the Hive terminal. Now let's not waste much time here, and we have a lot to learn. So let's continue with the next topics in our today's session. Now we shall try to edit the tables. Now we have created the new table, that is employee 3, and we have named the columns as ID, name, string, salary, age, and float. Now we shall try to make some alterations to our table. So the first alteration that we will try to make to our table is to rename our table as EMP table. You know that our employee table was named as employee 3. Now we are trying to rename it to EMP table. So we are using the keyword alter here. So just fire and enter and see if this is possible or not. Yeah, it is possible. The name has been changed to EMP table. Now let's try if it's completely changed or clearly changed or not. You can just type in describe EMP table semicolon. If we get the same column names in our description, then it should be changed. So there you go. We can see the same columns here. So we have successfully changed the name to EMP table. Now we shall also try to add in some more columns to our table, which is EMP table. So here we'll try to add in a new column that is the surname of string data type. So I'm doing that by using the keyword alter, followed by that table. The table name is EMP table, and I'm using the keyword add columns, and the column name is surname, and the data type of that column is string. So now let's fire and enter. And there you go. We have successfully added a new row to our table. Now let's try to describe our table again and see if the column has been successfully added or not. There you go. You can see the last row, which is the surname that we have added most recently. So this is how you can alter the table, and you can also change the names of the existing columns. Let's try to do that one as well. Now what I'm doing is I'm changing the column name to first name. So one of the column name in my table EMP table is the name, which gives me the names of the employees. So since I added surname, I'll change this column name from name to first name. So this is the command that I'm using for that operation right now. Let's fire and enter and see the result. Yeah, the change has been made. Let's describe our table. Don't forget the semicolon. There you go. You can see that earlier we had name. Now it's been changed to first name, and we also have a surname. Let's clear our screen. So that's all for alterations. Now we shall move ahead into our next major topic, or the data model, which is partitioning. So we have dealt with the first two data models, that are databases and tables. So we have learned how to create a database, and we have learned how to create a table. We have learned how to create internal or managed table, and also we have created external table, and also we have learned how to create an external table in a particular location in your Hive and load data to your table, and also how to alterate your tables, the column names, the name of your table, and how to add or delete new columns to your table. So far so good, and now we shall continue with the next type of data model, that is the partitioning. As we have discussed earlier about partitioning, it's completely similar to a school or a college. Just imagine that you are in a college and you are in computer science section. So a college has many branches. So maybe computer science, mechanical, and electronics and communications. So imagine your name is Harry. So if someone comes to your college and if he's looking for Harry, so there are many Harrys in your school. So if the person is asking specifically about you, that is Harry from computer science, then can you imagine how simple is this query? So you don't have to search for electronics and mechanical. You just have to come into the class computer science and search for Harry, and there you go, you're present. So that's how partitions work. To execute commands or to execute queries on partition, we will create a whole new database here. Let's start everything from fresh. So we'll create a separate database for executing our new data model, that is partitioning. So I'm creating a new database, that is Edureka student. So there you go. The database has been successfully created. Followed by that, let's use this database now. To use the database, you just need to add in the keyword use and name of the database. So let's fire and enter, and now we are currently using Edureka student database. Now let's create a table in Edureka student database. So here I'm creating a normal table, that is the managed table. So inside my student table, I'll be having some basic columns such as ID number of the student, name of the student, what is his age, and course. So you're not finding course here because I'm going to partition the table based on course. So here you can find the course. I'm using the keyword partitioned, and on what terms? So on the terms of course, I'm going to partition students. So we have discussed about our students CSV file, right? So here we have our CSV file, and the courses that this particular institute is offering are Hadoop, Java, Python, and yeah, so these are the courses that this particular institute is offering. So I'm going to categorize, or I'm going to partition these students based on their courses. So this is how I'll be partitioning them using this following code. So basically the table has all the columns, and I'm going to partition the table using course. So let's fire an enter and see the execution of this particular code. The partition has been done. Now all we have to do is try to load in our data. Before that, let's try to describe it. Let's try to see what are the columns present in our particular table student. So as you can see, the course column is present. Don't worry. The code looks that we have messed out course, but we did not mess the course column. It is present in the table. The only thing is that we have just partitioned it based on the course that we are going to offer. Now let's try to categorize the students based on their course. So you can do that by using the following code. We are going to load the data using the command load data local in path. So this particular folder, that is the student.csv, is in my local location. So that is home, Cloudera, desktop, student.csv. And I'm loading the data present in this particular location into the student, which is present in Hive right now. So I'm going to partition the student based on their course Hadoop. Now let's fire in this command and see the output. Yeah, now you can see some MapReduce jobs taking place. Yeah, the data has been successfully loaded. Let's now refresh our Hive. You can refresh your Hive or Hue based on two methods. The first one is just clicking refresh button on the URL, or you can also select a manual refresh. This is the manual refresh, and there you go, it's done. You can see the new database, that is the Edureka student database that we have right now created. And inside that, you can see the student table that we have created. And there you go. We have the file of students based on course Hadoop. Now we will try to add in few more students based on the course Java. For that, all you need to do is just replace the course name with Java. There you go. Here we had Hadoop course, and now here we have Java course. Just fire and enter, and you can see the output. Followed by that, we also had another course that is Python. So let's also execute a code for that. There you go, Python. So now we have uploaded student details into our Hive, and we have also partitioned using one of our data models, that is partition, into three categories that are based on Hadoop, Java, and Python. Now let's go back to our Hue and see if the three categories are done or not. Yeah, we need to refresh that. There you go, you have successfully refreshed. Still, there is no sign of Java and Python. Maybe a manual refresh could help. Yeah, the manual refresh has resulted in the two new files, which are Java and Python. So you have all the three partitions here, Hadoop, Java, and Python. Just enter them and you can see the student details. And now that we have understood partitioning, sorry, I forgot to mention, we have two types of partitioning, which are dynamic partitioning and static partitioning. So the static partitioning is in static or manual partitioning. It is required to pass the values of partition columns manually while loading the data into the table. Hence, the data file does not contain partitioned columns. You can see that we have sent the partition columns manually for Python, Java, and Hadoop. But when it comes to dynamic partitioning, you just need to do it once, and all the three files will be automatically configured and the files will be created. So now what is dynamic partitioning? So dynamic partitioning, the values of partition columns exist within the table. So it is not required to pass the values of partition columns manually. Now, what is this? Don't worry, we shall execute the code based on dynamic partitioning, and we shall understand this in a much better way. Now let's clear our screen. Now let's start fresh again. Let's try to create a new database for dynamic partitioning, and let's start again fresh. So here we'll be creating a new database that is Edureka Student 2. So earlier we created Edureka Student, and now we'll be testing our dynamic partitioning on our new database that is Edureka Student 2. So there you go, the database has been successfully created. Now we shall use this particular database. Currently we were in Edureka Student 1 database. Now we'll enter into Student 2 database. So we'll use it now. Now we are in Edureka Student 2. Now before we start up with dynamic partitioning, we have to set Hive execution to dynamic partition is equals to true, because by default the partitions that will be taking place in Hive will be static. So we need to convert that into dynamic partition by specifying this particular code. Now we are good to go with dynamic partitioning. Along with that, we need to execute another command which says partition mode would be non-strict. So by default, when you are partitioning using the static partition, the partition mode will be strict. So now you're specifying it to be non-strict. Now let's execute this. So there you go. We have executed the two required codes for that. Now let's create a new table. So the name of the table will be Edureka student, that is EDUSTUD, and this will have the same columns, which are the ID of the student, name of the student, course, age, etc. Now we will try to load in the data from our local path, that is home, Cloudera, desktop, student.csv into the table EDUSTUD. So the data has been successfully loaded and the size is 267 KB. Number of files is 1. Now comes the tough part. So here we are going to partition. So we will be partitioning the table based on the same thing, which is the course, and we will be separating the data using the comma. Now let's fire an enter. Now the table has been separated based on course, and now we will be loading the data to this particular table, which is the student part. So this particular table that we have created based on dynamic partitioning, and we are going to partition the data based on course. Now it's been created. So the student part table has been successfully created. Now the only part remaining is to load the data to this particular table. Now we will be writing a code. So using that code, the MapReduce will automatically segregate the data members or the students based on their courses. So the guys which are in Hadoop will be separated, guys in Java will be separated and loaded into different file, and similarly with Python. Now let's see how to do it using the code. So there you go. We are going to insert into student part, partition based on course, select ID, name, course, age from the table edu. So the data will be imported from the table what we have created here, that is Edureka student. So this particular location has the student.csv file. Now let's fire an enter and see if it's created or not. Fine. You can see some of the MapReduce jobs are getting executed. You can see we have 3 jobs. So first one is getting executed. We have 3 because one is for Hadoop, one is for Java, and one for Python. So this will take a little time. So this is the reason why I have chosen smaller CSV files, so to save time. When you take up the course from Edureka, then you can work on real-time data so that you get hands-on experience from real-time, and you can get yourself placed in some good companies with the experience what you gain from this particular course. So the stages have been successfully finished and the data has been loaded. Now let's see what are the data present in the particular table, student part. There you go. You have the output executed here. So these are the data members present in the partition student part. So these are the data members which are separated based on their courses. That is the partition based on their courses, that is Hadoop, Java, and Python. So now that we have understood dynamic partitioning and static partitioning, we shall move ahead into the last type of data model, which is bucketing. Once after we finish the bucketing, we shall enter into some query functionalities of Hive or query operations which can be performed in Hive. And followed by that, we will also learn some functions which are present in Hive and some of the other things like group by, order by, sort by. And finally, we shall wind up the session with joins which are available in Hive. For now, let's get continued with bucketing, the last type of data model present in Hive. So for that, let's again start fresh. We shall create a new database for that. Before that, let's go back to Hue and check if our partition has been made or not. Let's refresh. Also, let us make a manual refresh. So our database was Eureka Student 2 database. And inside that, we have the table that is student part. And there you go. You can see the files which are based on the partition. So 22 is for a different course, 23 is for a different course, and 24 is for a different course. And this is the default partition which has all the data members. As we discussed earlier, now let's start with the last data model in Hive, that is bucket. Now we have created a new database that is Eureka bucket. Now we shall also create a new table for that. Before that, we need to start with this particular database so we can use the command use Eureka bucket. Now we are in Eureka bucket. Now let's create a new table. So the table name will be Eureka bucket, and it will be containing the ID name, salary, age of the employees. The table is created. Now let's try to load the data. So the data file that we will be using is the same one, that is the employee.csv. So the data has been successfully loaded into the location. Now comes to the major part, that is the bucketing part. So to start bucketing in Hive, we need to use the command set hive.info.bucketing is equals to true. So that's done. Now we will cluster or classify the data present in this particular file using this particular code. So we will be clustering based on the ID, and we will be categorizing them into 3 different buckets. So let's fire in this command and see if it happens. Yeah, that's successfully done. Now we will override the data using the following command. Now we'll be inserting data into this buckets that we have made, that is 3 buckets, and we will override the table using this particular code. There you go. You can see some MapReduce jobs to be taken care of now. So one mapper and reducers are 3 for now. So stage 1 is getting done. So we should be having 3 tasks basically. So let's see what's the output. Stage 1 is finished. The process is finished and data has been successfully inserted. Now let's go back to Hive and check if it's done or not. So before that, let's do a refresh. Now a manual refresh would be much better. There you go. We have our database here, which is Eureka bucket. And inside Eureka bucket, we have EMP bucket, and that's our data, employee.csv. There you go. Now let's move ahead and understand the basic operations we can perform in Hive. So for that, let's start fresh again. Let's create a new database. I'm creating a new database for each and every option or each and every operation that I'm performing in this particular tutorial, just to make things or keep things in a sorted manner. So as you can see here in our particular file system, I have separated each and everything, like I have sorted everything. So for bucketing, I've got a separate database, and for partitioning, I've got a separate database, and for understanding how to create database and tables, I've got a separate database for that, just to keep things arranged and sorted. This looks in a much better way. So now let's discuss about the operations that we could perform in Hive. So I'm creating a new database again for this. So the database would be Hive query language. Now let's use this particular database. This creates a habit of learning things in a better way, or it's like a revision for the things what you have performed or learned so far. As you can see, the table has been successfully created. Now let's try to add in some data into this particular location. That is employee data. It's been successfully loaded. Now let's try to see what are the details present in this particular file. We can use in the command select star from the table Eureka employee. So there you go. These are the details or information present in the table Eureka employee. Now we shall see what are the functions that we can perform on this particular file. So since we discussed that the mathematical operations and logical operations can be performed on Hive, So let's try to perform an addition operation. So I'm selecting the column salary, and as we have seen here, the salaries are 25, 30, 40, 20,000 rupees for every employee. Now let me add in 5,000 more to each and every employee. So I'm adding the value 5,000 by using the addition operation. So let's enter. You can see we have added 5,000. So the first element was 25. Now it's 30. So similarly, all the other employees got 5,000 rupees hike all of a sudden. Now let's try to remove 1,000. So to do so, all you need to do is replace the addition operation with a subtraction operation, that is minus. Fire and enter, and there you go. Each and every employee lost 1,000. So the initial amount was 25,000. So removing 1,000 from that will result in 24. So this is considering the first initial values. So this is how it's working. Followed by that, let's also perform some logical operations. Let's clear the screen, and yeah, here I'm fetching for the employees who are having a salary equal to or greater than 25,000. So these are the employees which are having the salaries above or equal to 25,000. Similarly, let's execute another one which detects the employees with salaries less than 25,000. So we have got two employees which are having lower salaries, which are Amit and Chaitanya. Fine. So this is how you perform some operations in Hive. So now let's move ahead and understand the functions which you can perform on Hive. So in the same way, let's create a new database again. And let's use this particular database, that is Hive functions. Now let's create a table in this particular database. So the table is employee function and it's created. Now let's try to load in the data. Yeah, the data has been successfully loaded. And now let's see if the data is correctly loaded or not. Yeah, the data is loaded correctly. Now let's try to apply some functions in this particular data. So the first thing, or the first function I'm going to apply, would be a square root function, where I'll be finding out square root of the salaries of the employees. So there you go. The square root of 25,000 was 158 dot decimal numbers. So this is how you perform some basic functions on your data. Now let's try to find out the maximum salary. So yeah, the job is getting executed. You can see some MapReduce jobs here. I think the biggest salary would be from Sanjana. So the maximum salary is 40,000. So this is how it works. Since we are working on Cloudera and the system configuration is limited, the execution speed is a bit low. But if you're working in real time, then this process would take like a few seconds and it's done. There you go. You have the value 40,000 as shown here. So 40,000, the employee name is Sanjana, is the maximum salary. So that's what we got here. Now let's try to find out the minimum salary. So the minimum salary is 15,000, and who would that be? Yeah, it's Chaitanya with minimum salary 15,000. So that's how you do some operations in Hive. Let's execute some more operations, such as converting the names of the employees to uppercase. So you can see the employee names are converted to uppercase here, and similarly, let's try to convert to lowercase. So here you can see we have converted them to lowercase. So this is how you learn technology. You need to play with the technology. Then you'll come to know the advantages and disadvantages. So you can learn the possible ways where you can make things work out. This is how you do it. Now let's move ahead and understand group by function in Hive. So for that, we'll be creating a separate database that is group. Now we will use this particular database, that is group. So we'll type in command use group semicolon. Now we'll create a table. So the table has been successfully created. Now we will load data into this particular table. Now we will use the new CSV file, which will be employee2.csv. Now we are using this particular table because we have an additional column in this particular table, which is the country column. Now, as discussed before, we will be grouping the employees based on country. Let's see our data first. So we have countries such as USA, India, UAE. So these are the three countries that we are having in our CSV file. So we will be categorizing the employees based on their countries. So this is the particular command that we will be using. So maybe I made an error while creating the table. I think I gave a wrong table name here. So let's drop our table. So by mistake, I gave different table, that is employee order. So to drop a table, you just need to use the keyword drop and it's done. Yeah, the keyword table was missing. So you need to type in drop table and the table name and the table gets dropped. So we were supposed to create a different table that is employee group. So now let's create a new table that is employee group. Employee group has been created. Now let's try to add in data into the employee group. So we have used employee 2 here because the employee 2 has another column which is based on country. So the countries that we are having here are India, USA, and UAE. So we will be using the group by function here, and we will categorize the employees based on their countries. So there you go. You can see some MapReduce jobs getting executed. Yeah, there you go. We have categorized the employees based on their countries, that is India, UAE, and USA, and the sum of the salary. So the guys working in India and their summation of the salary is 90,000, and similarly UAE is nearly 1,05,000 and USA is 80,000. Now let's also execute a different command based on group by. So here we'll be using group by function, and we will categorize based on the country as well as the summation of the salary, which is greater than or equals to 15,000. So it's similar to the previous command. So you can see the data got executed and we got the same output. Now let's move ahead and understand order by and sort by methods. So for that, we'll create a new database orders. Now we'll use orders. Now let's create a new table again. So the new table is employee order and the table got created. Now let's load the data into this particular table. By now, I think you have some good practice of how to create a database, how to create a table, and how to load data into that particular table. So the data got loaded, and now we are going to order the data present in this particular table based on the descending order of their salary. So you're seeing some MapReduce jobs going ahead. So here we'll see the employees ordered based on their salaries in descending order. So the highest salary will be at the first place and the lowest salary will be at the last place. Yeah. So we have Sanjana at the first position with 40,000 as the highest salary, and she's working for UAE. And we have Chaitanya with lowest salary, 15,000, working for India. Now, let us also execute another command based on sort by. So first we try to execute a command based on order by. Now let's see the same output using sort by. So basically both work in the same way. So there you go. We have sorted the records based on descending order of salary. Now that we have learned what are the various operations that can be performed in Hive, that are the arithmetic operations, logical operations, and also some of the functions such as maximum, minimum, group by, order by, sort by. So these are the various operations and functions that you can perform in Hive. Now let's move ahead into the last type of operations that can be performed in Hive. Those are the joins. So for that, let's again create a new database. So here I'll be creating a new database that is Edureka join. And followed by that, let's use this particular database now. For that, we need to use the keyword use, and there you go. We are in Edureka join. Now let's create a new table for that. So the table will be emp join here. You can see that I forgot to mention semicolon. So now the table got created. Now we shall load the data into this particular table. So now I've created the first table, that is employee table, and I'm loading the employee data into this particular table. Now to perform join operations, we always need two tables. So in this particular database Edureka join, I've already created the first table, that is employee join. Now let's create second table, that is the department table, which will be present in the same database. So this particular table is a department table, which will be having the entities that are department ID and department name. Now let's load the data of department into this particular table. So the data has been loaded. So you can see the employee2.csv had the columns ID, name, salary, age, and country. And similarly, the department.csv has the entities which are department ID and department name. So the department IDs are present here and the names are development, testing, product, relationship, and admin and IT support. Now we have created both the tables and we have created or we have loaded the data also. Now we have four different joints available in Hive. They are inner joint, left outer joint, right outer joint, and full outer joint. Now let's perform the first type of joint, which is the inner joint. So in inner joint, we are going to select the employee name and employee department. And based on the employee ID and department ID, we are going to perform the join operation. That is the first join, inner joint. So you can see some jobs getting executed. So the map reduce task successfully completed. So the first set of join has been successfully finished and the output has been generated. Now let's try out the second type of join, that is the left outer join. So the only difference is that we're using the keyword left outer join. Now you can see one of the job got started. So you can see the output has been generated as well of the left outer join. Now let's move ahead and understand right outer joint. So for right outer joint, you need to use the keyword right outer join. Fire in the command and you can see the jobs getting executed. So you can see the output of right outer joint has been successfully executed or displayed. Now let's type in the last join operation, that is full outer join. So here I'm using the keyword full outer join. Fire in the command and you can see it's getting executed. So the output for full outer joint has been displayed here. So this is how the join operations are executed in Hive. So we have learned how to create database, how to create table, how to load data, and the various data models present in Hive, that are the tables, databases, partitions, bucketing. And after that, we have also understood various operations, that are the arithmetic operations, logical operations, and functions that can be performed in Hive, such as square root and summation, minimum, maximum. And after that, other operations such as group by, sort by, order by, and also the joins that are possible in Hive, which are inner join, left outer, right outer, and full outer. So each and every operation that could be possibly executed in Hive have been displayed in this particular tutorial, and everything is sorted here in the base of databases, and you can get all the details about this. And you'll also get the code that I have used in the description box below, and you can try it out. And also, if you're looking for an online certification and training based on Big Data Hadoop, then you can check out the link in the description box below. And during the training, you'll get to have real-time hands-on experience with real-time data. You'll learn a lot of things in the training. And so far, so good. Now, we shall also discuss some of the limitations of Hive. So Apache Hive limitations. So Hive is not capable of handling real-time data. Hive is capable of batch processing. If you have to work with real-time data, then you have to go with real-time tools such as Spark and Kafka. So it's like Hive will actually take in the data. For example, imagine you're working on Twitter and you have 1 lakh comments on a particular post. So if you had to process those 1 lakh comments, you'll have to first load all those comments into Hive. Then you need to process it. So while you're loading the data from Twitter to Hive, you may also get a few more comments that you will be missed out. So it's not preferable for real time. Hive is preferable for only batch mode processing. So followed by that, it is not designed for online transaction processing. So online transaction processing is something which only works in real time. So Hive cannot support real time processing. So last but not the least, Hive queries contain high latency. Yeah, Hive queries take a longer time to process. As you've seen, I've taken a smaller CSV file and the time consumed to process such a small CSV file was taking so long. So yeah, Hive queries contain high latency. So these are the few important noticeable limitations of Hive.
Now let's just start with the databases. A database is a systematic collection of data, and a database management system supports storage and manipulation of data, which makes data management easy. For example, an online telephone directory uses a database to store data of people like phone numbers and other contact details that can be used by service provider to manage billing, client related issues and handle fault data, etc. So, in simple words, we can say a database management system provides the mechanism to store and retrieve the data. There are different